Hi guys, today let us study about the principle and working of a 4-stroke diesel engine. Well, this engine works on the diesel cycle and hence the name. The principle is similar to that of the 4-stroke petrol engine, but except the fact that here a fuel injector is used in place of a spark plug and also only the air enters inside the cylinder during the suction stroke, whereas in petrol engines both the air and fuel mixture used to enter. Now let us see the working of this engine. At the beginning of the suction stroke, the piston is at its top dead center and is about to move towards the bottom dead center. At this instant, the inlet valve will open and the exhaust valve will remain closed. The downward movement of a piston produces a space in the cylinder head and hence a partial vacuum in the cylinder is created. From this, the air from the atmosphere is drawn inside the cylinder through the inlet valve. The suction stroke ends when the piston reaches the bottom dead center and also the inlet valve is now closed. Hence, on the completion of this stroke, the crankshaft makes half of a revolution. Now, during the compression stroke, the piston which is at BDC now moves to the TDC. Both the inlet and exhaust valves will be remain closed. As the piston moves upwards, the air in the cylinder will get compressed, due to which the pressure and temperature of this air increases. The compression takes place adiabatically. When the piston is about to reach the top dead center, a metered quantity of diesel is injected in the form of fine sprays to the hot compressed air. This is done by a fuel injector. Hence, combustion of fuel takes place as the diesel spray mixes with the compressed air. This combustion of fuel will take place at a constant pressure and hence the name of the engine is also a constant pressure cycle engine. With the completion of this stroke, the crankshaft rotates by another 180 degrees, that is another half revolution, and hence completing one full revolution. The energy required by the piston for both these strokes is produced by a charged battery. Next, when the power stroke begins, both the valves will remain closed. As the combustion of fuel takes place, the burnt gases will expand and hence exert a large force on the piston. This will cause the piston to reciprocate rapidly from the TDC to the BDC. This force is then transmitted to the crankshaft through the connecting rod. Hence, now the crankshaft will rotate at high speeds as the reciprocating motion is converted into rotational motion. The crankshaft then transmits the power through clutches, gears, etc. to turn the wheels of the vehicle. Also, it is important to note that the expansion of the gases in this stroke will also take place adiabatically. Now, near the end of the expansion stroke, the exhaust valve will open while the inlet valve will still remain closed. Some part of the burnt gases, due to their own expansion, will escape out of the cylinder through these exhaust valves. Now, the exhaust stroke begins when the piston will move from the BDC to the TDC. The energy for the stroke is supplied by the flywheel, which has absorbed energy in the previous stroke. As the piston will move upwards, it will force the remaining burnt gases to the atmosphere through the exhaust valve. Hence, when the piston reaches the top dead center, all the exhaust gases is forced out and hence now the exhaust valve is closed and hence one working cycle is complete. Here also we can observe that the crankshaft completes 2 revolutions in each cycle. The same process will be repeated again and again to produce continuous power. Now let us study the PV diagram for the 4-stroke diesel engine. During the suction stroke, the suction of the air will take place at an atmospheric pressure. This is represented by the line AB in the diagram. The compression of the air in the cylinder will take place adiabatically. This process is represented by the curve BC. Also in the compression stroke, the combustion of the diesel fuel will take place at a constant pressure. This is represented by the line CD in the diagram. Also, in the power stroke, the expansion of the burnt gases will take place adiabatically. The curve dE represents the adiabatic expansion. Also, the pressure drop which will take place in the exhaust stroke due to the escaping of burnt gases on their own expansion will occur at a constant volume. Hence, this is represented by line EB. Finally, the escaping out of all the exhaust gases takes place at an atmospheric pressure. Hence, the line BA represents the process in the diagram. The 4-stroke diesel engines are mainly preferred for heavy-duty applications. Hence, they are used to power buses, trucks, tractors, and marine applications. Thank you.
Wow, that's impressive! You have completed a magic today. For more videos, subscribe. Join our Facebook group and Instagram page for group discussion and live magazine videos for exam preparation in an hour. We start at ClassFly community for students to learn from a friend in a simple way and support them in their own languages. If you are willing to be that one friend who saves us at the exam night preparation, then please join us by visiting classfly.in.